today to talk about test mixers. There are a wide range of test mixers you can buy on the market. Starting here we have a auto ranging one. This is a Fluke 179. Fluke are one of the sort of leading manufacturers of multimeters and measuring equipment, or digital measurement in equipment now. You get cheaper versions, or more basic versions I should say, such as this one here, Rapid Online. That's an electrical store online. It's a good meter, it's very useful, accurate, but it means you have to select manually what range you want. So on here you see for resistance with the omega symbol, we have to measure, if we was measuring a 180 ohm resistor, we'd have to put it onto the 200. If it was a 2000 ohm, you got that. If it was a 12,000 ohm resistor, we'd have to put it on a 20,000 ohm range. On the Fluke one here, the auto ranging, you just turn it straight onto resistance, and you can see there it's got auto range on the screen, stating that it will range itself automatically. As soon as I put that on a resistor, it will go to the desired range. The main test though we do, really the most simple test we do with a multimeter is continuity, which if you look at a meter is generally symboled by that sound symbol there. When testing for continuity, if we touch the two probes together, we should get a buzzing noise. This just shows that there's a continuation in the whole circuit. So we can use this if we've soldered components together or testing a circuit. Check there's no breaks in the wire at all that maybe we struggle to see with our eyes, or damage inside the cable. We can use that when testing simple circuit boards like this one here that's been made. You can test it to check that there's no links between tracks. If we test up here where there's a lot of soldering done, I'll put the two test probes on there, or there. It's showing us that there's a continuation between those top three tracks, there, there and there. So if we look closer at the soldering in the top corner, we can actually see that there's a couple of whiskers join that together, and where some bad soldering has been done. So this will have to be looked at later on. Come further down the board, we can look at these connections here. There's no continuity between them, they've been soldered correctly. Nice neat lines of solder. Further again, if we come down here, you can see on the back there's a wire link joining this track to that track there, from the resistor down to the power supply. So if we turn the board over, we can check that that wire is intact and that there's a good connection. So if I touch on here, touch on there, so I've just touched right on the edge of the board and there's a good connection, nice sound buzzing. If we want to test further into this for more complex components such as resistors, we can test resistance. As I said before, this resistance is shown by an omega symbol, so ohms on a meter. As soon as I turn it on, it's got the ohm sign in the corner, it's saying OL for overload, which is saying there's too much resistance there, you can't see a connection, there's no continuation. So if I put the two test probes together, as such, they're showing us 0.1 to 0.2 ohms of resistance. So I asked my assistant Luke, why are we getting resistance? We're not measuring anything, we're just measuring from loop to loop.
There's resistance in the wires into the meter.
Right, so there we're explaining basically that no matter what circuit we're looking at, or whether it's good or bad, there will always be resistance. So, to test a resistor, there are many ways. You don't need to use a meter. If I want to test, let's say I should get another resistor, such as this one here. It's quite a small little delicate resistor, and you look at it compared to the test probe, it's not very big. But I mean, how do you think we'd normally measure this, Luke? Do you know?
There's two options. You can either use your meter or a chart which will allow you to calculate the colour band.
Right, so looking at this, we can tell we have a blue, a grey, a black one and a gold. So what do those four bands mean, Luke?
I don't know. Can you tell us?
Well, I suppose we can try. Here you see here, this is another nice little resistor colour code guide from Rapid Electronics. This shows us that here the first band, the states down there, which is the first number. You've got that one, the second band, which is the second number. Your third band is your multiplier. So it tells you how many noughts you're going to have on the end of it.
Your last band, where we've got the gold, is a tolerance. So straight away we know that resistor is a 5% tolerance resistor. So it's a mid-range resistor, it's not bad. So now first one is blue, so we've got 6. Then we've got, what do we say the next colour was?
Grey.
Grey, so that's 8, 68. Then we have black, which is 1 I believe, 0, sorry. So, 680 we're saying. Let's check with a meter to see what it says. I'll put the meter on. I'm not touching it with my hands to eliminate more resistance. 68 ohms. So, sorry, misread there. Black is actually 0, multiply 0, brown is 1, 0. So yeah, that's correct. Looking at our colour code there, so some bad prints on it with black. So that is in fact a 68 ohm resistor, and we're getting exactly 68.1 there, or 68, 68.2, which is a good reading. When can we not maybe use this colour code, and when we will have to test it then, Luke? Why don't we use this all the time?
Because resistors can be damaged in the circuit, or they can be, the view of their colour band can be obstructed, so painted over.
So as Luke says, here you can see this resistor here. It's been in the circuit, and also it's quite a worn out resistor by the looks, the work fault. This actually been painted over, as someone's painted over a circuit to protect it from damage and wear. It's been discoloured, so I cannot actually see the colour band on it. So we can use a test meter like this here. We put on. That's actually reading 2,213 ohms. So yeah, I mean that's accurate enough, isn't it? So would you trust that reading, Luke?
Yes, Wood, after you should prove in that the reading of this is correct to what your meter said, I can trust in your meter.
So what Luke's saying now is, after measuring this resistor here, which we could see the colour band of, as such, there we've got 68 ohms. We reference that resistor across to the colour band chart, and we check it is 68 ohms, so we know almost the meter is calibrated by ourselves there. We've shown that it is reading accurately. Then we can test the unknown resistor to check that it is accurate. So, what else can you measure with that multimeters then?
You can measure voltage and ampage.
Right, so let's have a little look at voltage next. Let's move these resistors out. What setting do you think we should have it on for voltage then, Luke? Do you reckon this points out?
If you're testing DC, you should have it on the one with the solid line.
Yep.
And if you're testing AC, have the one with the squiggly line. We're testing batteries today, so we're going to have it on the DC setting, which is the solid line.
Okay, so from what Luke said there, is correct. You've got DC up in the corner on my meter next to voltage. Turn the light on, you might be able to see it a bit easier. But also ranging down the bottom. You can see it jumping around a little bit. Don't let that bother you, that's just the movement of the lead, so it's millivolts, it's tiny amounts. When we actually get onto a solid voltage, that will disappear. Alright, so let's look at some batteries. We have here 2 batteries. Which one, just looking at them, would you have thought the bigger battery maybe more powerful? I mean, that's massive compared to that. So surely that's got to have more voltage, right? What do you think?
Logically, yes, but
Well, let's have a little look. So on a multimeter you've got 2 leads. Red is generally positive, black is negative. If we look at these batteries, the 9 volt PP9 batteries, the little starry shaped one there is normally the negative, and the other one is normally the positive. If I put that on, this battery we're reading 9.39 volts.
which is good for a 9 volt battery.
So if you ever turn the leads the wrong way round, it won't blow your meter up or cause damage as such, but we'll read some minus 9.39 volts. So what does this help us with, Luke?
Helps you when you're, if you can't actually see the positive or negative, you can see minus 9.3 volts is correct, you've just got to turn your phone around.
What Luke's trying to explain here is that helps with polarity. If we didn't know what pole was what in this battery, we didn't know what was negative and what was positive. By going as such, we know the leads around the wrong way, so if I swap them round, reading solid 9.38 volts there, and that also shows us that that is a positive terminal and that is a negative terminal. So let's look at this big battery here. I mean, see what it reads. As we go on the battery, that is actually reading 5.826, well, 25 volts. Try it again. 5.8 volts. So that's actually under 6 volts. That's why it's gone on to a different format, because it's under 6 volts, it's under a different range. So, surprisingly, looking at those two batteries there, this one actually, well, has a lot more voltage in it than that one. So, what's the next thing then we can do, Lee?
We can test what ampage they are putting out.
Yeah? So, well, before that, just to show to you the accuracy sometimes of older meters as well, if I turn my fluke off there, which is probably most recognised and used modern day digital multimeters, we'll move that to the side, and we'll pick up another type of meter. This is probably one of the first, sort of, well not first, but an older version of an analogue multimeter. Got to show you this earlier, this is almost antique, probably older than us here. So on this one here, it's very simple to use if you look at the display. This one here, we're measuring DC, so we make sure that arrow's on DC. Then we use this side to put the range on. It's a ranged meter. So you've got volts DC there, and we've got it set to 10, a range of maximum of 10 volts. If we want to measure AC, we would turn that to AC, and select the AC current on here, AC voltage there. Just put it to DC. It's a range of 10 volts. As you look on the scale, you've got at the top, it's quite hard to see, 1 to 10, 10 being there, 0 being there. So if I put that down, I put my leads on a small battery, see that's actually at 9.2 volts.
So how do you know you're looking at that prone straight on to see you're reading the voltage accurately?
That's a good question, Luke. As you see, there's a mirror in the middle of that scale. See that mirror there? So the idea is, as I put the test break, if I do it on this one, so it's in the middle of the meter, so it's nice. As we look at that, the idea is you have to look at the probe, the little needle, so you can't see any doubles. If you look at a slight angle, you'll see a double picture of it. You'll see it twice, once in the mirror, once on the needle. You want to get both those reflections are spot on, and that'll let you know you're looking at the needle straight. Does that help you?
Yeah, it does, thank you.
So always after using it, remember to turn it off just to keep it in a good position. So there shows you that you get all different types and shapes of meters. So, to measure current, amperage, we can work it out generally using Ohm's law. I equals V over R, which is current equals volts over resistance. For using that, I know personally what this 68 ohm resistor is going to do with a 9 volt current. What sort of volts power supply, what sort of current we're going to be getting on. So what would I put the meter to and do with the meter if I want to measure current?
When I measure current, I'm going to put the meter to the amps and switch over your test leads to the 10 amp plug socket.
Yeah. On this at the moment though, it's measuring AC. Why is that? Do you know?
No, but how do you change this?
Well, on this fluke one here, because it's auto range, it's trying to get minimalistic controls on it as such. You see the yellow writing above the sum of the symbols.
Yeah.
That means it's almost at a dual function. So as we're on amps, it's amps AC for standard. If I push this yellow button up here, it'll change it to the sign above in yellow DC. So now we're on auto range in DC amps. So if I put this resistor into a circuit with this power supply, you should be able to see there we have 120 milliamps of current through that circuit, which is what I'd expect for a resistor of 68 ohms and 9 volt circuit. So there shows us